Hello friends, we are starting a book about physics. Its name is Physics Fundas. It has been written by Karan Damodar Darshani. He was a student of, it was written when he was a student of BVM, Vallabh Vidyanagar, BTech. He has dedicated this book to his beloved parents and you, the reader. The index is about, the book is about of roughly, one can say that 80 pages. The index contains introduction, what is motion, force, work, energy and power, rotational motion, thermodynamics, waves, ray optics, and last one is electricity and magnetism. So first of all, today we are going to start with our introduction, that is its chapter 1. I am a student of engineering and physics is one of the fundamental subjects whose understanding is must for the students like me. So I go through some concepts. Most of the students find physics tough. Here I try to simplify it so that understanding of the subject will grow and try to improve the interest of the students. Here all the basic concepts of physics like motion, force, work, energy, power, rotational motion, thermodynamics, waves, ray optics, electricity, and magnetism are included. In all the chapters, the basic stuffs are only discussed. Once the reader go through the book, reader will be able to refer another books of experts. Used some examples which are related to the day-to-day life. Some interesting concepts like Faraday's cage, which are not in the syllabus but uses the concepts of electricity, also has been included. I hope this will help you as it helped me a lot while formatting it. So now we have reached to the second chapter of a book named Physics Fundas, written by Karan Damodar Dasani. Chapter 2, Motion. Motion. Motion is a very wide concept and is applicable from atoms to planets. But here we will limit ourselves to the massive objects. If the position of an object varies with time, then the object is said to be in a motion. Rest. If the position of the object remains constant, that is, not changing with respect to time, then it can be said that the object is at rest. Frame of reference. It can be defined as the plane from where the observer is observing the motion, or in other words, it is an imaginary axis with reference to which we define the position of an object. For example, suppose you are traveling in a bus and when you observe any tree or building which you know is stationary, that is at rest, but still it seems that the tree or building moves in your opposite direction. Similarly, you are also in motion for any other person which observes you from the bus station. Another example, if two persons, Mr. A and Mr. B, starts walking together with same velocity, then Mr. A is not in motion for Mr. B, but at the same time both of them are in motion for any other person, Mr. C, which is observing from any other frame of reference. Hence, We can conclude that if an object is at rest in one frame of reference, it can be in motion in any other frame of reference simultaneously. Types of motion: one dimensional motion, that is also known as 1D motion. If any one coordinate of an object changes with respect to time, then the type of motion is one dimensional. Two dimensional motion, which is known as 2D motion also. If any two coordinates of an object changes with respect to time, then the type of motion is two dimensional. Three dimensional motion, 3D motion. If all the three coordinates of an object changes with respect to time, then the type of motion is three dimensional. How to identify the type of motion? Let us assume that an athlete running a 100-meter race can be considered as a one-dimensional motion, provided that the track is straight and the ground is flat throughout. Similarly, while running a marathon, he is performing 2D motion while the ground is perfectly flat. But if he climbs a mountain, then it is 3D motion. Hence, 3D motion is observed generally. For 1D and 2D motion, we need to predefine or bound the motion with some conditions. Scalar: the quantity which can be completely defined by its magnitude only is scalar. For example, mass, distance, speed, etc. Vector: the quantity which requires magnitude as well as direction to be completely defined is regarded as vector. For example, displacement, velocity, etc. Distance: the length of the path traveled by an object is known as distance. Its unit is meter. It is a scalar quantity. Displacement: the shortest distance between the initial and the final position of an object is called displacement. Its unit is also meter. It is a vector quantity. How to differentiate distance and displacement? For reaching from an initial point x to a final point y, we have infinite number of ways, that is distances. So far, some initial and final position, we may have a number of distances. Contradictorily, displacement is always unique. So far, two fixed points, we always have a unique displacement, which is the shortest distance between the 2 points. For example, as shown in figure, from reaching from point A to B, here 4 possible ways are shown, that is path 1 to 2, 3 to 4. But as the path 2 is the shortest, it's the displacement, while rest all is the distance. For a body in motion, the distance can never be 0 or negative, while displacement can be 0, positive as well as negative. Speed: it is a quantity which signifies how fast an object is moving. It is defined as rate of change of position of an object with respect to time in any direction. It is a scalar quantity and does not depend on direction. Mathematically, it can be shown as v is equals to s by t, where v is speed, s is distance, and t is time. The unit of speed is meter per second. Uniform speed. If an object covers equal distances in equal interval of time, then it is said to be moving with constant or uniform speed. Average speed. The ratio of the total distance travelled to the total time taken by an object during its motion is known as average speed. It is given by v is equals to total distance travelled upon total time taken. Instantaneous speed. The speed of an object at a given particular instant of time is known as instantaneous speed v, where v is equals to dx by dt, where dx is small change in a distance and dt is a small change in time. Velocity. The rate of change of displacement of an object with respect to time is known as velocity. It is a vector quantity. Its unit is meter per second. Speed of an object is always positive, while velocity can be positive as well as negative. Also, speed and velocity of an object at a particular instant may or may not be the same. Every vehicle is equipped with speedometer, which measures the speed, not the velocity, because to measure velocity we need to consider the direction. As shown in figure, an object starts its motion from point A on a zigzag path. Now, if it covers equal distance in equal interval of time, it is said to be moving with uniform speed. But here, as the direction of motion changes continuously, the velocity of the object keeps varying. Relative velocity. The rate of change of position with respect to time of one object with respect to any another object which may either is in motion or rest is known as relative velocity. So, the velocity of one object with respect to the other is known as the relative velocity. For example, suppose you are standing on a railway platform. A goods train with a velocity v1 passes by. Then the relative velocity of the train with respect to you is v1 as you are stationary. Now, if you are in a train which moves in opposite direction as that of goods train and with a velocity v2, then the relative velocity will be v1 plus v2. Hence, the relative velocity of the same goods train moving with constant velocity is different depending on the observer's state of motion and the frame of reference. Sign convention. If two objects move in the same direction, then the relative velocity is the difference of them, while if the direction is opposite, the relative velocity is the sum of both of them. Acceleration. The time rate of change of velocity is known as acceleration. Its unit is meter per second square. Mathematically, acceleration A is equals to dv by dt, where dv is small change in velocity, dt is small change in velocity. Opposite of acceleration is deceleration or retardation. So if the object is accelerating, it can be said that its velocity is increasing And if the velocity is increasing, then the object is retarding. So acceleration is an important parameter to define the motion. Thank you very much, guys. Keep listening and love physics.